All right, Eli, how'd you get involved with this project?
Okay, well, I got involved with this project because my grandfather, who worked at the University of Dayton as a professor in thermodynamics, had died, and we were looking through his library and we found a copy of his thesis and my uncle's thesis for their PhDs. And I looked through his was about muscles being treated as thermodynamic engines, and then my uncle's was about the algorithm, blind adaptive signal processing algorithms, and I thought that was pretty neat. So my uncle, who is still living, I asked him about to teach me about the stuff, and so he taught me about it, and I thought it was really cool. And he told me he had never really like tested them, well, one of his algorithms with actual like real world tests using lights and stuff. So I said, okay, I'll do it, and I designed this prototype to do it. And I also had to do school thing, a Believe in Ohio project, and so I decided why not make this my Believe in Ohio project.
Cool. Now, just run through the basic parts of the prototype.
Okay, this is the Arduino microprocessor, and it's basically the what's running the calculation or the algorithm itself. This is the emitter array, I call it, and it's just will turn these LEDs on and off, and I made the Arduino turn them on and off at random. And then this is the receiver array, which is with these photoresistors. So the way I would measure it is if more light was coming in it, then it would change the voltage, and I would measure those voltage changes to show if it was a 1 or a 0. And what I wanted was all these emitters would be different colors, and so they would, and I wanted this one to only take red light, this one green, this one blue, oh no, blue, green, yellow. And so I put these colored filters, they're kind of falling out right now, in these boxes so it would filter out, not completely, but some of the light, because the algorithm can't filter out like every spectrum without a little help from like actual filters like these. And so that's basically the actual hardware. The way the algorithm works is I'll take a bunch of data that would have been gone through some sort of, I don't know, like mix up, where in this case it's just the light being, if this green's on and this yellow's on, they would somewhat mix, and it would seem like maybe the blue receiver's on when it's really not on, and that would throw off all data being sent. And the way it works is it is a modification of the least means square algorithm, where except it's blind. Instead of me knowing what it should be, it's me kind of using the statistics of what it should look like and changing the output to make it match those statistics. I didn't really design the algorithm, but my uncle designed the algorithm, and it was in his thesis. And so the algorithm works more or less like I would just take the error, and then I would slowly reduce the error until the error would like flatline, and then I would say, hey, this is the lowest error I have, so I'll use this for now on, and it would get close enough that the Arduino would say, okay, I know what a 1 or 0 is, and then it would be true 100% of the time eventually.
And that's what we see in the graph as
Yeah.
it starts to work down to 0.
It will eventually work down to 0 as it's like kind of like spikes up and down. The graph is the past 50 trials, if it was right or wrong. So like if 50% of them were wrong, it would be a 0.5, and if 20% were wrong, it would be 0.20, and then it would go down, and eventually goes down to 0. I think it starts around like 1 or 50%, somewhere around there, and it kind of wobbles up and down, because that's it trying to figure out what's the right way to weight all of these, because it uses like weight matrices. Sorry, I forgot the plural of that. It uses weight matrices on these lights, and each light is its own row in the matrix, and I would weight each light differently. For if I'm doing the red, say I'm trying to unmix the red receiver, then it would have a different set of weights than from the blue receiver, the green and yellow receiver.
So in the graph, it's the time frame is sequenced in a way that you can see it, so it's slowed down to some degree. Correct?
Yeah, the way I think in an actual practical application, if you would use it, you wouldn't use these photo resistors because they're quite slow at changing their pace. They can only like change their voltages a bit low. Their resistance is about 10 times a second, and that's kind of slow. If I could only send 10 ones or zeros per second for like data transfer, it would have to be a much more sophisticated like way of changing voltages due to light input. And you could even put the filters directly on the receivers. It was just too much of a hassle for us to do, so we just kind of put them on this little styrofoamy box.
So you proved your uncle's thesis would actually work.
Well, I proved that that specific algorithm from his thesis had practical merit because it actually worked.
Great. What are some of the practical applications for this, possibly?
I mean, you could do it for, there's a like company in Britain called Li-Fi, and they are trying to do like for lights, you could send Wi-Fi data that would normally be Wi-Fi data. You could send that through your light to like your smartphone or your laptop or any other smart device that can hook up to the Wi-Fi or the internet. Okay. You could also do it for like I don't know, cars or something, that anything that could use light that is uses on and off keying. You could basically use this algorithm with it. So like infrared, I think there's certain infrared applications you could do it with too.
Very good. All right. And did any of your math work, any of your calculus classes help you with this, or did you pretty much know what to do already?
For calculus, the most calculus I did was like the gradient. So I mean, I guess calculus 3. But it was mostly linear algebra, and I had my geometry teacher lent me his linear algebra book, which I read. It was like, I think, first year in linear algebra. I forget like who wrote it or something. But he went to, I forget where he went to, it was like sophomore year.
Yeah.
But he lent me that book, I read it, and basically from that book, I was able to like decode the what my uncle had written, and then I would just talk to my uncle and ask him about like the certain mathematical things that I just couldn't understand without some help, because some of it was had some like statistics that I was like unaware of and stuff.
Gotcha. So you knew electronics before from building robots and things and such, right?
Yeah, I knew electronics from building robots and just from looking online and yeah, just
finding
robots
answers.
and just I would just tool around Google and just look out, oh, these are how you do parallel resistors and all that jazz. And so it wasn't too hard to build the prototype. The hardest part was programming it, to be honest.
Right. And what did you program it in?
Arduino's like proprietary software. Like it can only read this software. It's kind of like based off of C.
Off of C, so you had to learn a little bit about C's.
Yeah, C's syntax and whatnot.
Great. And so mathematics and the hardware part of it coming together with this, you had to program the algorithms into C, and then.
Yeah, I had to translate like a theoretical mathematical or linear algebra algorithm into something a computer could read.
Gotcha. And then you randomly had the lights flash on and off, which we see in the video.
The lights will flash on and off randomly and 10 times per second, and I did not at any time like swap the information between the emitter and the receiver, except to check if what the algorithm's output was actually correct. That was the only time I would compare the two actual data.
That was pretty cool. So you enjoyed doing this and were happy with the results. And what did you learn that would need to be tweaked possibly in the future? The little things that you learned to improve upon later. I know you had some struggles here and there.
I would, if I were to make it better, I would maybe use like a microcontroller, like design a microprocessor that would actually be just to run this algorithm.
Okay.
And then it would just, wouldn't have to really program it, but it would be like a lot more hardware and stuff.
Right.
And I would switch out these so I can maybe have larger, more data per second, and maybe use a more sophisticated filtering system, like actual light filtering system. But other than that, I would change that. Also, no, I think I'm trying to think of more. Maybe cleaning up the code a bit and making it run faster, because I'm fairly certain that the code I have, from talking with some people who know about coding and stuff, isn't really the most efficient. But I wasn't really going for efficiency, I was going for more of it works. And now it works, see how it works, and then maybe later I'd make a faster, more efficient, like better working prototype that would work.
Excellent.
Yeah, in like all varieties of situations.
So you're going to college next year. What your interests are specific at this point to some degree that it has to do with mathematics.
Yeah, I want to be.
But you're not sure exactly. I mean, you've changed your mind a few times. So.
I have changed my mind a few times, but I'm pretty hard set on math because I really like math a lot.
No, I mean within the realm of mathematics.
Yeah, within the realm of math. So I could see
you've gone from like engineering to pure math to actuary math.
Yeah, all that.
If that's what it's called.
Right now I'm kind of more into pure math, but I could see myself being like an engineer, or really anything that uses math to some degree.
Right. Excellent. All right. Cool.
Okay.